Okay, this is 9-5, which is all about an ellipse. What's an ellipse? Well, it's an oval, is what you're used to calling it. Let's look at this. This is page 413 in your book, just to get some of the terminologies. It has a center, just like a circle does, and we're going to use HK because we've been using that for everything else. It has two focus, says plural, which is foci. If you were to tie a string to each of those and then stretch your pencil out and go around, that's how you would make the ellipse. This plus this is always going to be a constant amount. Now, what we're going to focus on are the vertices. The vertices are the ends of the long part, and then the co-vertices or the co-vertex are the ends of the short part. It's almost like these are a radius. They're not, by definition. Remember, a radius is the same all the way around a circle. But that kind of gives you an idea about what... Okay, so we're ready to take some notes. This is 9-5 ellipses. I'm going to draw in a set of axes. Okay, and just try to keep an ellipse that's kind of the same up and down, and then the same right and the left. But try not to make it be a circle. Make it more oval. You know what the center is. And we're still going to use HK for the center, like we've done on the other kinds of functions. We're going to have what we call a major axis and a minor axis. Now those change depending on whether you have a long ellipse or a tall ellipse. The major always goes with the longer portion. At the ends of the long portions, you will find a vertex, and the plural is vertices. On the short end, you have co-vertices, plural for co-vertex. There is a general form for an ellipse, x minus h squared and y minus k squared. And that should look very familiar. We've done lots of functions that use a pattern similar to that. Now, these are going to go over a squared and b squared. And that's going to give you a 1. These are the lengths from the center to the vertex or the co-vertex. If your A is bigger, then the X goes with it, making it an oval that goes long ways. If your B is bigger, that goes with the Y, making it an up and down oval. All right, example 1. Let's do x squared over 64 plus y squared over 100 equal to 1. It's the standard form for an ellipse. Notice you're not adding or subtracting anything to the x and y. That tells us that the center is at the origin at 0, 0. Now, 64 happens to be 8 squared, and 100 happens to be 10 squared. Notice that the 100 goes with the y. That's telling you that it's going to be an up and down ellipse. Okay. Just a real quick sketch here. The center is on 0. On the x, it's going to be the square root of 64, or 8, to the right and to the left. Now think about whether those are the vertices or the co-vertices. Hopefully you said co-vertice because it goes with a smaller value. The square root of 100 is 10, so on the y direction, you're going to go up and down by 10. And those will be the vertices. Now, if I could draw a perfect oval, This one's almost circular. There's not a lot of difference between 10 and 8, but there is some difference. Now, in addition to finding the center on your homework, you need to find the coordinates for the vertices and for the co-vertices. So on the y's, you're adding and subtracting 10 to the center of 0. So that is 0, 10, and 0, negative 10. For the co-vertices, you're adding and subtracting 8 to the x value. So 8, 0, and negative 8, 0. All right, here's one for you to try, example 2. X squared over 16 plus y squared over 8 equals 1. Locate the center, the vertices, and the co-vertices. No need to sketch it. Matter of fact, it's going to come out with a radical, so you may not want to even try. Go ahead and pause the video while you do this. The center was also at 0, 0, like example 1. This is the bigger one. So the square root of 16, which is 4, gets added to the x value. So to the x value, you're going to add and subtract 4, giving you 4, 0, and negative 4, 0. The shorter version goes with the y. You're going to add and subtract the square root of 8. So the x stays 0. This one, you add radical 8, and you subtract radical 8. All right, now we're ready to do 2 of them that don't have the center at the origin. All right, for example 3, let's do x minus 3 squared over 4 and y minus 1 squared over 9. Your center, HK, gives you 3, 1. Your vertice, remember that's going to go with the bigger one, which in this case is the y. You're going to add and subtract the square root of 9, which is 3. Your co-vertices, the smaller value goes with the x, and you're going to add and subtract the square root of 4, which is 2. Okay, so I'm going to leave my x values alone. The y, 1 plus 3 is 4. 1 minus 3 is negative 2. For the co-vertice, I'm changing the x by 2. 3 plus 2 is 5, leaving the y 1. 3 minus 2 is 1, leaving the y 1. And the cool thing is you can make a real quick sketch to see if it works, if it makes sense. So 3, 1 is going to be my center. 3, 4, 1, 2, 3, 4. And 3, negative 2 should be the same distance apart, and they are. 3 up and 3 down. And then to the right and the left of the center, I'm going to have 5, 1, and 1, 1. Notice those are each 2 away from the center. All right, here's one for you to do on your own. I would probably jot it down and then pause the video while you give it a try. Let's do x plus 5 squared over 36 and y minus 2 squared over 25. So on that, I would like you to figure out the center, the vertices, and the co-vertices. Pause the video while you do that. Okay, did you get the center to be negative 5, positive 2? And then we're ready. The vertice, the bigger number is 36, so you're going to add and subtract 6 to the x value. So you have a negative 5 plus 6 is 1, and then a negative 5 minus 6 is negative 11. Sorry for the loud dog. For the co-vertice, you're going to add and subtract 5 to the y value. So negative 5, and then 2 plus 5 is 7, and then 2 minus 5 is negative 3. All right, hopefully that makes sense. Make sure you check the assignment carefully. It's kind of a pick and choose from some of the problems because we're not doing all of this section. This is the last assignment for the week, so definitely review, review, review.